Hey guys, so in this video we're looking at factoring trinomials where the leading coefficient isn't 1. I prefer magic method for factoring these. There's other ways to do it. This is just kind of one version. In terms of our flow chart, we're still looking for a GCF first, and then when we count the number of terms for this style, there's going to be 3. We're going to see the leading coefficient is not 1. We're also going to see that there aren't perfect squares on the ends. We don't learn that till the next section, but that will be the next step in our kind of process of elimination. So when both of these things fail, so it's not a 1 in front and there's not squares on the ends, then it's going to be this last kind down here, which is magic method, and that's what this section's about. So this is also probably the hardest section of the quarter, heads up. Has a few steps here. Step 0, always factor the GCF out. Step 1 is multiply a times c, and what the a and the c are is when we're in this form ax squared plus bx plus c, which is sort of our general form for a quadratic, it's the first and the last coefficient. So I'll just do this example as I go through these steps. This one doesn't have a GCF, so I can go straight to step 1, multiply a times c. So that'd be 5 times 8, and that would be 40. And then what numbers multiply to be AC, this 40, and add to be B, which in this case is the 22. So it sounds like 20 and 2 would multiply to be 20, or sorry, 20 and 2 will multiply to be 40 and add to be 22. There you go. And then, so that's a lot like what we saw in section 5.2, but here it's a little bit different. We write the factors with an extra factor of A with the numbers from step 2. So we'd go 5x and then plus 20, and then we duplicate the 5. So right now we have an extra 5 going on, and then the plus 2. And then reduce out the extra factor of A as the last step. So right here, my extra 5 is going to come out nicely. I could do it here, but I have fractions, and I do it here and it goes in nice. We want to look for the one that's kind of like a GCF. And then that's going to give me x plus 4. 5 goes into 5 once, and then 5 goes into 24 times, and 5x plus 2. And that's the method. So let's look at the next example. 14, 26, and 4. So there is a GCF of 2. Super important to get that out of the way. It'll make it a much easier problem if you do. They're actually kind of hard to get right if you don't. So taking the GCF out, and that leaves me, oops, I need an x right there, 7x squared, 13x, and 2. And my next step is to multiply a times c, so that's going to be 7 times negative 2 will give me negative 14. And I need 2 numbers to multiply to this and add to be positive 13, so it sounds like a 14 and a negative 1. And then I just do my 7x, my other 7x, and put these numbers in. Again, the order doesn't matter. And then just reduce out that extra 7, which will come out nicely right here. And that'll give me 2, and then x plus 2, and 7x minus 1. So these next to it, have you try. So 5 times negative 3, negative 15, multiplies to negative 15, adds to be negative 2, will be negative 5, and positive 3. So we'll do our 5x with a minus 5, and our other 5x with a plus 3. And then 5 divides out nicely on this one. It's not always the first one, it just happens to be I'm writing them in that way. So x minus 1 and 5x plus 3. Here, GCF of looks like 3. Easy way to spot that is if you go 15 is 3 times 5, you know 5 doesn't work, so then you just have to check 3 and see if that one does, and it goes into both. So I'll take a 3 out front, 5x squared, this will be an 8x, and then that'll be a 13. And what I did up there, I guess I should have said, is I picked the one that wasn't very interesting. 24 has lots of stuff in it, 3 and 13 would have been a good choice too. But so many things, different things going to 24, it's not the one. I would pick the limited one and then use that to check the others. So then here I can go 5 times negative 13, and that's going to be negative 65. So it sounds like a positive 15 and a negative, positive 13 and a negative 5. And so that does multiply to negative 65 and adds to be positive 8. So here I'll go 5x plus 13 and 5x minus 5. And so the extra 5 is going to come out right there. And then that'll leave me 3, 5x plus 13, and x. Remember that 5 goes to both, so minus 1. These are the ones I would do. So this example just has an extra letter running around. It's not a big deal, but just to show one. And then this one's going to be what happens when the numbers are terrible. So let me show you these two. So here I'll just go 3 times 4 and get 12. I need two numbers to multiply to 12, add to be negative 8, so it sounds like negative 2 and negative 6 you get that done. So here I'm going to go 3x minus 2, and just like the ones in 5-2, it's the same, I just need a y on the end is all. And here I'll go 3x minus 6, and then with the other y on the end. And then I have an extra 3 floating around, so that will divide out nicely on the second term, because 3 goes into both. And then that's going to make this 3x minus 2y and x minus 2y. And then this one, so this, if I multiply it out, I'm going to get negative 600, which is sort of a big number, and there's a lot of things that multiply to be 600, and I'm trying to find the ones that are 1 apart. So sometimes it's easier, instead of multiplying, if you just kind of leave them as the numbers and maybe factor a little bit. So I'll think of the 20 as a 4 times a 5, I'll think of the 30 as a 5 times a 6. And the 4 and the 6 aren't necessarily right, but just as a starting place. And then I'll see if I can kind of group up the numbers and see if I can get them to get 1 apart. On this one I got lucky, and the 4 and the 6 were good. So if I had 5 times 5, that would be 25. If I have 4 times 6, that would be 24. And those are 1 apart, so the 25 is going to be my positive, the 24 is going to be my negative. So I think that's sometimes with the bigger numbers, it's easier to just kind of break them up a little bit rather than to put them together first and then break them up. So here we'll have 20x plus 25, and then 20x minus 24. So I always have to divide out whatever the extra number I've put in is, and so far those have all been primes. This time 20 is a composite, which means it factors to more than just 1 in itself. And so this time it's gonna divide out kind of in both factors. So if I look at these and I go, what's the biggest thing that goes into 20 and 25? That would be 5. And if I do the same thing here, biggest thing goes into 20, 24, that would be 4. 5 times 4 is that 20, that extra 20. That should work every time. If it doesn't, something's gone wrong in there. But so sometimes you have to do it to both factors to get the extra piece out. So reducing, I'm going to get 4x and plus 5. And here I'm going to get 5x minus 6. Let's see, these are the matched ones that have you guys try. So 6 times negative 3 is negative 18. So it'd have to be a negative 9 and a positive 2 to get that negative 7. So that's going to give me 6x minus 9, and then don't forget the y. And then here we're going to have 6x and then plus 2y. So I have to divide out 6, so it looks like I can do 3 right here, and it looks like I can do 2 right there. So that's going to put me at 2x minus 3y. And 2 into 6 would be 3x plus the 2's would cancel, so just a y. This one, so here's a great example as to why it's really important to get the GCF out of the way. 21 is 7 and 3, so if you figure out 3 doesn't go in, then it's going to have to be a 7 if anything, and 7 does work. So instead of having to figure out what 21 times 77 is and then adding to 98, which would be way too much work, if I get that 7 out of there, then I can see a little better what I have. So 7 goes into that one, 14 I think. Let's see, checking my notes over there, yes. And then 7 goes into 77, 11. So instead of 21 times 77, I get to go 3 times 11. So that's how big a deal that getting the GCF makes. So definitely look for the GCF first. So 3 times 11 is going to give us 33, and then we got 3 and 11 is the only thing it factors to. That adds to our 14. So we're just at 3x plus 3, and 3x plus 11. And we'll divide out that extra 3 right here. And that's going to give us 7x plus 1 and 3x plus 11. Okay, so these next two have GCFs. 7 doesn't go into the 52, but there is an x squared everywhere. So I can get that out of the way. And then I have 7x squared minus 52x plus 21. And this is a great one to do the factoring trick, because, so this is 7 times 21. 21 has to be 7 times 3, that's it. And so then I can much more easily see 49 and 3 right there. So then I can rewrite this piece, x squared, 7x minus 49, and 7x minus 3. Divide out my extra 7 right here. And x squared, x minus 7, 7x minus 3. Here it looks like I can do a 2 and an r. So I'm going to go 2r. That'll leave me 10x squared plus 7x plus 1. 10 times 1 is 10, multiplies to 10, adds to be 7, so 2's and 5's. So I'll have 2r, and then 10x plus 2, and then 10x plus 5. So I can divide 2 out right here. I can do, 5 right there. Pretend like that looks like a 5. And we'll have 2r, 5x plus 1, and then 5 goes into 10, 2x plus 1. Okay, these last couple are tough, and these are the ones I'd have you try. So we'll get an x squared out of the way. 13x squared, 19x minus 14. So again, 13 times 14, it's kind of a big number. So I would probably think of it as 13. And that 14, I would just think of as a 2 times a 7. Once I do that, this would have been a really hard problem, but now I can just kind of see right there, there's 26 and 7, and those are 19 apart. 7's going to be my negative. So it's a good little trick for finding the factors when the numbers get a little bit bigger. So that'll be an x squared out front. We'll have 13x plus 26, 13x minus 7. I got a fake 13, so I'm going to divide that right here. And then that gets us x squared, x plus 2, and 13x minus 7. And then this last one, looks like there's an r everywhere, and that's it. 5's and 7's, won't play with the 8 and the 6. So we'll just take an r out front. So 8x squared plus 6x minus 35. So 8 times 35, again, kind of a bigger number. So maybe I'd try, 35, it's probably just going to be a 5 and a 7. And then 8, maybe I'll try 2 and 4. And I need numbers that are 6 apart because this multiplies to be a negative. And so doing that, I can kind of see right there, there's a 20, and on the edges there's a 14, and those are 6 apart. So 14 would be negative, and to get a positive 6 there in the middle. And then I can just rewrite it now with my 8x plus 20 and my 8x minus 14. And then here, 8 and 20, best I can do is 4, so that means this is going to have to be 2 to get to the 8, and I double check and I go, yep, that is 2 for 14 and 8. So then I'm left with r, 2x plus 5, and 4x minus 7.